Good morning, everyone. So we'll start with our next topic, which is curves, which is basically an application of theoretic reversing principles that we have studied before. So let's first discuss what a curve is. So a curve is basically a way to join two intersections. So if you have a road project or a railway project, so you would have different alignments, and when you want to join them, so you cannot join them at an angle. So that is when a curve comes in, which helps you to join them in a very smoother way, so that those traveling on that straight do not feel that sudden change of direction. So if you see this diagram over here, so what we have is we have this point A and B, and then we have this point B and the point C. So imagine that you continue the direction on both the sides, and this is the direction of flow of traffic from A to B, and this has to be the direction afterwards, right? From B to C and its continuation. So that has to be the direction of traffic afterwards. Now, if you extend these lines, they intersect at this point B. So if there weren't a curve, so what would happen? You would travel from here to here, and then you would have to go at 90 degrees or any other angle, which is very sharp. So in order to avoid that, what we do is that we join the 2 points using a curve. So a curve allows you to change your direction of flow in a way which is very smooth. So you don't have to take any sudden change of direction. So everything can happen in a very efficient way. So this is basically application of a curve. Now we have two different types of curves. We have curves in the horizontal plane. So when you have a curve in the horizontal plane, that would be called as a horizontal curve. And if you have a curve in the vertical plane, so that would be called as a vertical curve. Now, the curve in the vertical plane usually has a parabolic path. So it's a parabola. Whereas in the horizontal plane, it's usually a circular curve. So if you join, if you take this point and if you take this point, they would be radii of a circle, which is at point O, which is obviously not in the field, but if you extend these two radius, they will join at one point, which would be the center of a circle. So this would be a circle with a center at O, and at 2 points on the circle, you would have a curve. Whereas in a vertical curve, the curve is usually a parabola. So this is basically the difference between a horizontal curve and a vertical curve. So let's see what are the different types of horizontal curves. So we have discussed vertical curve already. So horizontal curve can have different types. It can be a simple curve, compound curve, reverse curve, transition curve, and lemniscate curve. So now we'll discuss each of them one by one. But before that, just a few very basic definitions that we should be familiar with. So the first definition is degree of a curve. So a degree of a curve is the angle a unit chord of 30-meter length subtends at the center of the circle formed by the curve. So like we discussed, that a curve is basically an arc of a circle. So imagine this diagram over here, which is a circle, and the 2 points given are A, B. And if you join the 2 points to the center of the circle, they would join at the point O. So if this is the point O, they would join over here. Now this is, we are looking at the curve from the top. So this is a plan view. Now on the road, you would have just a curve like this. It's two straight lines beginning to form a curvature, and you would have a curve. But if you extend the two radius from the 2 points, they would join at the center of a circle O. And over here, they have drawn the whole circle. Now what they're saying is that if you draw a chord of 30 meters on that circle, the angle that that chord makes at the center of the circle, which is this D, so that is called as a degree of a curve. Now, based on this, we can classify the curve as a 1 degree curve or a 2 degree curve, depending on if this is 1 degree or this is 2 degree. So now let's see what is the relation between degree of a curve and the radius of a curve. Now let's see this diagram over here. So you have again 2 points A and B. Now let's say that the distance between AB is 30 because we just took a unit chord, a chord of 30-meter length. So this distance AB is 30 meters. And again, they join at the center of the circle, which is at point O. And this angle over here, this would be the degree of the curve. And half the angle, if you draw a straight line above from point O, which intersects the line AB at the point C, that means the distance AB and the distance CB would be 15 meters. And the degree of the curve would be divided into two. So now you would have d by 2 on the left and d by 2 on the right. Now, if you see over here, we have, if you take the triangle AOC, now what do we have over here? We have the angle AOC is equal to d by 2. And in the triangle OAC, we have sine d by 2 is equal to AC over OA. So this is a right angle triangle now. You have one angle which is equal to d by 2. You have the angle at the point C, which is equal to 90 degrees, because this is a line that we drew by ourselves. And if you take the sine of the angle d by 2, you get AC over OA. Now, AC is equal to 15 meters, we just discussed. And OA is what? OA is the radius of the curve. So you get sine d by 2 is equal to 15 over r. And if you readjust the equation, radius becomes equal to 15 over sine d by 2. Now, there's this relation in triangles that when the angle is very, very small, the sine of the angle becomes equal to the angle, approximately equal to the angle. So this is an approximation that we usually take. So sine d by 2 becomes approximately equal to d by 2. So if you remove the sine and if you take the angle now in radians, so you multiply it by pi by 180 in the denominator and readjust, uh, you get radius is equal to 1719 over d, where d is the degree of the curve. So this becomes a relation between the radius of a curve, sorry, radius of a circle, and between degree of a curve. So this is a relation that we would be frequently using afterwards as well. So one more concept that we need to study is super elevations. So I think you must have studied this sometime before as well. So super elevation, the concept comes from a circular motion. In a circular motion, there is a force that tends to move the particle away from the center, which is called as a centrifugal force. Now, imagine a vehicle which is traveling on a road at a speed and it tries to take a very sharp turn. So there's a good chance that if the speed is a lot and if the curvature is sharp, then there's a good chance that the vehicle can topple over. So in order to avoid that, what is usually done in construction is that along the curve, so let's say if this is the curve, so along the outer end, which is this end is kept slightly at an elevation from the other end. So usually the road would be at a level, but along the curve, the outer end is kept at a little elevation from the inner end. So this end would be at a higher elevation and this end would be at a lower elevation. So this is called as super elevation and it is done to counterbalance the centrifugal force. So more the elevation of the outer end, the lesser the chances that any vehicle can turn over. So now let's see the relation. If you see this figure over here, you have this object, this one, which has weight is equal to W. And This is the road on which it's traveling. So I will call this point as A and I'll call this point as B. So if there were no super elevation, so the distance between AC would be um, a plane distance. But since there is a super elevation, there is a distance between the point B and the point C. So the actual distance between the point A and B is actually inclined distance. So if you give super elevation at the point B, so now we're talking about a section of a road. Now we're not looking at it from the top. We are cutting a section along the width of the road and we are looking at that section. So because of the super elevation H that we have given over here, there is an angle that forms and we call this as theta. The angle is BAC, which is equal to theta. And this B or G represents, in the case of roads, it represents the width of the road. And in the case of railways, we call it as the gauge, which is the width of the railways, usually called as gauge. So it is that. And remember, we are taking a section. Now, the vehicle or any object which is traveling on this road or railway track, it has a weight of W, which is acting over here in the downward direction. But since it is on an inclined surface, so that means we can convert this weight into two components. One component would be W cos of theta, which would be along this axis, and the other one would be W sine of theta, which would be along the inclination of the road, parallel to the inclination of the road. So since it is traveling on an inclined surface, so we have centrifugal force over here. Remember, its equation is mv square over r. And if you convert it into weight, so it becomes W v square over gr, where v is the velocity at which it's traveling, and we have g and r in the denominator and W in the numerator. So this is trying to move this vehicle towards the right side or away from the road or towards the outer curvature of the road, and the weight, a component of the weight, which is W sine of theta, is trying to move it towards the other side. So, and how do we get this? Because it's an inclination theta, so this angle is equal to theta as well. So that means that if you draw this axis now, and this angle is theta, so you get W cos of theta acting downwards because it is angle is in the vertical plane, and W sine of theta acting parallel to the surface of the road. So now this W sine of theta should be equal to the centrifugal force for the vehicle to remain in equilibrium, right? So we get this relation over here. Now see what is the sine of theta. Over here we have this triangle ABC, which forms a right angle triangle. So sine of theta becomes equal to h over b, where h is the super elevation, the amount of super elevation, which is the extent to which the outer end is raised, and b is the width of the road. So it becomes W into h over b is equal to weight v squared divided by gr. Now, um, if you rearrange, you can calculate the super elevation that needs to be provided so that the weight and the centrifugal force, they can counter each other or they form an equilibrium. Now, when you design the super elevation, you take the worst case scenario. So you would take the maximum weight of the vehicle that can travel on the road or the maximum velocity which is allowed for vehicles to travel on that curve. So whenever you travel on the curve, you must have seen that there's a speed limit which is written. So these designs that we are going to do, they are for a specific speed and for a specific curvature. So based on that design, they give a safe limit of the speed. So based on that, taking the worst case, you can calculate the super elevation. And there are also some guidelines as well that we will see in a moment. That is called as centrifugal ratio, which is the ratio between centrifugal force and the weight of the vehicle. So P over W, and you replace the values for centrifugal force and the weight, so you get V square over GR. And the Allowable value for centrifugal ratio in roads is 1 over 4, and in railways it is 1 over 8. So just basic guidelines. You would find these different in different design codes, and you can use these guidelines to basically design super elevation. So now we'll talk about the types of horizontal curves. So the first type is a simple circular curve, a simplest base case, which is very common and which is also used to derive other types of horizontal curves as well. So in a simple circular curve, uh, we have a curve which consists of single arc with a constant radius connecting two tangents. It is said to be a circular curve. So if you see this figure over here, so like we discussed before, you have the point A and the point B. So this is the direction of travel, and the point B and the point C, which is the direction of the travel after you take the turn. And then you join the 2 points using a curve, or you make the transition easier using the curve. Now, the point at which the curve begins is called as T1, and the point at which the curve ends is called as T2. So now your direction of travel is along the curve like this. And before T1, you're basically traveling in a straight line, and after T2, again, you're traveling in a straight line. But between T1 and T2, you would be traveling in a curve. And if you join these points with the center of the circle, which is imaginary, but like we discussed before, so you would have two radius. Now, in a simple circular curve, this arc has the same radius throughout. So if you draw infinite number of lines from the arc to the center, all the lines would have the same distance because all of them are radius of the same circle. So this is a definition of a simple circular curve. Now, if you see the compound curve, the difference is that it's a curve which consists of two or more arcs with different radii. So you would have more than two arcs, or you would have uh, different radiuses in the curve. So that is called as a compound curve. So a compound curve is basically a combination of two or more simple circular curves. Because what we said in a simple circular curve is that it has one arc which has the same radius throughout. In a compound curve, you would have more than one arcs with different radii. So that's a difference. So if you see this figure over here, um, we would divide this curve into, let's say, three different parts or two different parts. So you have point AB, your initial direction of travel, point T1 from where the curve starts, the first curve starts, the point 2 at which the first curve ends, and from the same point where the second curve starts, and the point T3 where the second curve ends. And after that, from point 3 T3 onwards, you travel in a straight line. So basically, from the point A to T1, traveling in a straight line. From T1 to T2, you're traveling on a curve which has a different radius. From point T2 to T3, you're traveling on a curve which has a different radius. And afterwards, you're traveling again in a straight line. So the difference is that over here, these 2 points would join at a distinct center of a circle. So all these radiuses would be equal. But after T2, the radius changes. So this curve is now meeting at it has a different center of a circle. So because the radiuses are changing. So that means curvature of one curve would be different and curvature of the other curve would be different. Over here, they've shown just two, but you can have three, four, five, or as many combinations as desired. And this depends basically um, on actual conditions, actual ground conditions where you are trying to construct the curve, because usually you don't have that spare land on which you can give one bigger arc. So you can join them with different simple circular curves, a combination to make a compound curve. So I hope you understand the difference. Afterwards, we have a reverse curve. Now, reverse curve is very common in hilly areas. So what's distinct is that a reverse curve consists of two simple circular curves in the opposite direction. So their centers lie on opposite side of the curve, and the radius of the two curves can be same or they can be different. That doesn't really matter. But the distinct feature is that you have two curves which face opposite direction. So let's see. Like before, AT1, this is your direction of travel before you give any curve, and T3D, this is supposed to be your direction of travel after you give the curve. Now, like I said, usually these curves are given in hilly areas or in cities where there is restriction of land, where you do not have access to entire land. So you have to navigate your way, you have to be creative, and that's where a reverse curve can come in. So once you give a reverse curve, what happens is that from the point T1 to the point 2, you give one curve. And if you see this whole figure, this is basically one simple circular curve, something that we have discussed before. But after D2, this is not your direction of travel. Your direction of travel is this one. So from the point 2 to the point T3, you give another curve which has the opposite direction. The center of that circle lies on the opposite end. It's very interesting. So after that, you travel from point T2 to T3, and afterwards, you travel in a straight line. So this is the distinct feature of a reverse curve, that you have two simple circular curves which may or may not have the same radius, but it's definite that they would have opposite direction. So that's what a reverse curve is. And then we have a transition curve. So transition curve is also called as a spiral curve, or it's called as easement curve. So as the name suggests, in a transition curve is basically a simple circular curve, but at the beginning points of the simple circular curve, before and after, you give uh, a curve which has very less curvature. So this is actually um, an opposite way of doing the same thing which super elevation does. So instead of giving excessive super elevation, what you can do is you can opt for a spiral curve, which can basically serve the same purpose, avoid the cars from toppling over or avoid the vehicles from toppling over. So how does this work? Like before, your direction of travel, AT1. Now at the point T1, before what we did was this point marked the start of circular curve. But now this point does not give you the start of the circular curve. From the point T1 to this point over here, I'll call this as T1 dash. So from T1 to T1 dash, we have a portion which is a curve, but the radius is much more. So you can say that the curvature is much lesser. It's very smooth. Now from the point T1 dash to this point, which I would call as T2 dash, you have the simple circular curve. And from the point T2 dash to the point T2, you again have a transition curve. So basically you give two curves at the beginning of the simple circular curve and at the end of the simple circular curve. And these two curves make it easier for you to get on the curve and afterwards to get off the curve. So it acts as a transition between straight road and a curve. And once you are trying to get off the curve, again, a transition between the curve and the straight road. So this is called as a spiral curve or a transition curve. because usually a simple circular curve, the radius is such that it's very difficult for you to get on from a straight road directly onto a curve which has a specific radius. So in order to make it easier for you to go from a straight line onto a curve, you give two arcs at the beginning, at the end, which makes it easier for you to make a transition. That's why the curve is called as a transition curve or an easement curve or a spiral curve. And at the end, we have lemniscate curve, which is not exactly included in the course, but it's a distinct form of horizontal curve, which is usually given when the deflection angle is very large, and we'll get to that what deflection angle is. So I'll end this video here over here, which was an introduction, and in the next video we'll start with uh, design of a simple circular curve.